Stage Anandan to all the students. My name is Professor Swati Rajput and I work as Assistant Professor in SIRT College, Bhopal. Today, I'm here with a new series of second semester CSBS Principle of Electronics. And this was my lecture number 2. And in this session, I will explain you about the transistors and principle of electronics. In this, I'll explain about CE, CB, and CC configuration of transistor. So let's get started. So basically, you all know what is transistor and what is its mechanism, principle. In last lecture 1, I have explained you about its type, NPN and PNP, its working, and what does transistor work like. So in short, I'll explain you what is transistor. It is a semiconductor material. What semiconductor material is? Maybe it can be silicon, it can be germanium, and it has 3 terminals, or that what I told you about that. It has 3 legs. What are they? Emitter, collector, and base. Okay, 3 legs. What are they? Emitter, collector, and base. Okay, these are of 2 types, NPN and PNP. In last lecture 1, I have explained you the working of both the types, NPN and PNP. Okay, what is the principle of operation? The transistor work based on movement of charge carrier. It can be either be holes or it can be electrons, and control a large current using a small current. Small base control a base current control large collector current and emitter current. This is why transistor can amplify signals and it can be used like a switch. What does the switch do? Either it can be turned on or it can be turned off. Okay. Operating region of transistor, there are 3: cutoff region, active region, saturation region. Okay. And it has 3 configuration. This number 3 you all should remember. 3 legs, 3 operating regions, and 3 what configurations. Okay, configurations. You should remember all these terminologies because the main thing is these words, these terminologies. Okay, so it has 3 configuration. What are they? Common base, common emitter, common collector. If you remember the 3 legs or the 3 terminals, you can write this. Okay, in all these add common base, common emitter, common collector. You should also know these words: CB, CE, and CC. The CC configuration is also called emitter follower, because the output voltage of the emitter follows the input voltage. Okay, now we will study all these 3 configuration in detail because it is also asked in examination. Okay. So let us start with common collector configuration. As I have shared this screen with you all, then why it is called as common collector? You should all know why it is called as common collector. In this configuration, the collector terminal is common to the both input circuit and output circuit. Okay, so this is common collector configuration. Then what is the working principle? When the input voltage is applied to the base emitter junction becomes forward bias and emitter current increases. The output voltage appears across the emitter resistor and output voltage closely follows the input voltage. For silicon transistor, Vout is equal to Vin is equal to 0.7 volts. Okay. In CC configuration, this is the important thing that we all should remember, that is IE is equal to IB plus IC. That is, what is IE? That is emitter current. IE is emitter current. IB is base current and IC is collector current. Okay. The advantages of CC configuration. What are the advantages of CC configuration? High input impedance, first advantage. Second advantage, low output impedance. And third advantage, good current amplification. What are the disadvantages? Voltage gain is less than 1 and it is not suitable for voltage amplification. Then we will study about common emitter configuration. What is common emitter configuration? It is C configuration. It is most widely used in transistor configuration. It is mainly used for voltage amplification, current amplification, and power amplification. Okay. In this configuration, emitter terminal is common to input circuit and output circuit. Here you can see this. Okay. Input and output circuit. What is common? Emitter. Shows the relation. What is the relation over here? Collector current IC, collector emitter voltage VC, and for different voltage IB. What are the advantages of C configuration? High voltage gain, high current gain, high power gain, and good amplification, and it is widely used. What are the disadvantages? Output is phase reverse, moderate input output resistance, and more noise in CB configuration. Okay, what are the applications? Amplifiers, audio amplifiers, voltage amplifiers, and RF amplifiers. What is a switching circuit? Digital electronics and logic circuits. Oscillator used in waveform generation. These are all the advantages. The common base CB configuration. CB configuration we'll study about. This is the third configuration. Now we'll study. Configuration is one of the three basic transistor configuration. Okay. In BJT, that is bipolar junction transistor. The three transistor configuration are CB, CE, and CC. Okay. In this configuration, the base terminal is common to the input circuit and output circuit. Here you can see the base terminal is common in both NPN and PNP transistor. Here E is the emitter, B is the base, and C is the collector. What is the working principle? The CB configuration work on the principle that electrons injected from the emitter pass through the thin base region and collected by the collector. The transistor control current flow through semiconductor action. Here, emitter, collector, and base. By the name, we can figure out what is its work. Okay, so the emitter emits. Emitter will, what it will do? It will emit what? Electrons or holes. Okay, what will the base do? It acts like a passage between the two, emitter and collector. Okay, whatever is emitted, either holes or electrons will pass through the base. It is very thin. It is not very large. In emitter, it is highly doped. Means all the electrons or holes that will be present, it will be highly doped. Okay, highly filled in that. And what is collector? Collector, by the name, you understand that it collects. Okay, what it will collect? Anything that is emitted by the emitter. Either it can be holes or it can be electron. Then we can see the current relationship. Emitter current, collector current, base current. Emitter current is I, collector current is IC, base current is IB. And what is the relationship? IE is equal to IC plus IB. Okay. Current gain in CB configuration, alpha is equal to IC upon RD, where alpha is the current gain, slightly less than 1, usually between 0.95 and 0.99. Current gain is less than 1. Advantages of CB configuration. What are advantages? High voltage gain, good frequency response, low input capacitance, and stable operation. What are the disadvantages? Disadvantages are current gain is less than 1, very low input resistance. Applications are high frequency amplifier used in radio frequency communication system. Impedance matching, useful where low input impedance is needed. Voltage amplifier. Okay. Thank you to all the students for connecting with me in lecture number 2. For any questions or queries, you can comment down below, and do wait for my lecture number 3 because many of the concepts of transistor will be cleared in it. Thank you.